All right, welcome. If you've spent any time securing traditional data centers, the big question is always, how do you take all that battle-tested knowledge and apply it to the cloud? Well, today, let's walk through how to architect a security fabric that is truly cloud-native, piece by piece.
So the real question is, how do you evolve your security posture? How do you get from that rigid on-premises world of physical firewalls with fixed capacity to the elastic, automated world of the cloud? Well, that's exactly what this architecture does. Think of it as the cloud-native version of your traditional DMZ. And today, we're going to build it. Okay, so every good fortress needs a strong outer wall, right? In our case, that fortress begins at the very edge, and our first layer of defense is the AWS Web Application Firewall, or as you'll always hear it called, WAF. Now, WAF operates at layer 7, and if you're not a network engineer, just think of layer 7 as the application layer. It's where your users are actually clicking around, sending data back and forth over HTTP and HTTPS. WAF's entire job is to be the intelligent gatekeeper at this layer, filtering out all those malicious requests before they ever get a chance to touch your servers. And what's really cool is you can see exactly what kind of threats we're talking about here. We've got the big ones you always hear about, right? The OWASP top 10 vulnerabilities like SQL injection and cross-site scripting. But it also handles things like volumetric layer 7 DDoS attacks and just all that nuisance traffic from bots and scrapers trying to steal your content. So where you put this thing is absolutely critical. The best practice, and really the only way you should do it, is to position WAF at the very edge, right in front of your content delivery network like CloudFront or your load balancer. Why? Because you're stopping attacks with maximum efficiency, as close to the attacker as possible. The big takeaway here is this: stop the bad guys as early as you possibly can. All right, so we've secured the perimeter. Now let's move one layer deeper into our architecture. Because after that initial screening, we need a central hub for much more advanced threat inspection. And this is the role of the gateway load balancer. This right here is the critical piece of the entire architecture. The Gateway Load Balancer, or GWLB, is basically a transparent traffic director. It lets you seamlessly insert a whole fleet of third-party security appliances. We're talking serious next-generation firewalls directly into the network path without you having to bend your network into a pretzel to manage complex routing. So how does it do this? What's the magic behind it? Well, it uses a protocol called GNV. And what that does is it basically wraps the original network traffic inside of an outer packet. Think of it like putting a letter in another envelope. This lets the security appliance inspect the traffic like it was a physical bump in the wire, all without changing the original source and destination IPs. It's totally seamless. And the operational benefit here is huge. It massively simplifies things. Because GWLB is handling all the traffic routing and making sure sessions go back to the same appliance, your next-generation firewall gets to do one thing and one thing only: inspect traffic for threats. It doesn't have to be a router anymore. It gets to be a pure, lean security machine. And this right here, this is where the cloud just shines. Your firewall capacity is no longer limited by a physical box you bought 3 years ago. Your security appliances live inside an auto-scaling group, so when a traffic spike hits, the fleet scales out automatically. When things quiet down, it scales back in. This is on-demand, elastic security capacity that you just can't get with traditional hardware. Okay, let's put all these pieces together. We've looked at the WAF at the edge and the GWLB in the middle. Now let's walk through the complete end-to-end traffic flow for a single user request coming into this architecture. So let's trace the path. A request comes in from the internet and boom, it's immediately inspected by WAF. If it looks clean, it gets passed to the application load balancer. Now the ALB routes it over to a gateway load balancer endpoint. This is the key step. The GWLB transparently sends that traffic to our firewall fleet for deep packet inspection. Only after that firewall gives it the all clear does the traffic return to the ALB to finally get sent to your application. Notice that at no point is traffic just trusted. It's inspected, then inspected again. That right there is zero trust in action. So, after putting all of that together, what have we actually built? Let's step back for a second and just summarize the powerful capabilities you now have at your disposal with this design. What you have now is a truly powerful, multi-layered defense. You've got that layer 7 WAF protecting you from web exploits at the perimeter. You have this incredible, transparent, and fully automated inspection fabric using GWLB and your firewall fleet. And it's all assembled into a true end-to-end zero-trust model. This isn't just a collection of services, this is the blueprint for a modern, secure, and resilient cloud architecture.
Look, mastering this architecture is a core competency for any modern cloud security architect. But it also opens up the next big question. Your perimeter, your north-south traffic is now incredibly robust. So what about the traffic inside your network, that east-west traffic between your services? Is your internal access control just as smart? That's the next fortress you have to build.